So for conclusion for today, the interaction between process unit can be summarized as you have your individual component probabilities. So to determine what is your overall process failure probability, you need to determine what is your individual component probability first. Then through the interaction between these units, you can find out later what is your overall probability. So between these two interaction, there are a few types of interaction between the process units, okay, between this individual component, okay, is either through the parallel interaction or series interaction. So the individual component will interact through parallel or series. Then through this interaction, you can determine what is the overall process failure probability. So as you look, you still need the information from the individual component, the overall process, and also what type of interaction between this individual component. So we look further, what is the parallel interactions? So the parallel interaction is a simultaneous failure of numbers of components in parallel. In other words, okay, individual component failure probabilities must be multiplied. Okay, you need the n function, okay, for this parallel interaction. So n, the logical n function or the logical function for n, okay, this is the logic gate, okay, logical function or logic gate of n, okay, did you remember? Okay, you have your logic gate of n, or n whatsoever, okay, during your physics, okay, in your SPM, okay. So this logical function, okay, or logic gate of n will be used for the parallel interactions, okay. Total reliability for parallel units can be considered as R, okay, reliability is equal to 1 minus the summation of the R, okay, 1 minus R. So these are two equations that can be used for parallel interaction, okay. So what we call as a parallel interaction is the simultaneous failure, means you need at least, okay, at least two or more failure happens on the same time for the process to be in fault or to be in incident, okay. You need the combination of failure, okay, the parallel interaction, okay, the keyword is the combination of failures, okay. That's why we use the logical gate of n, okay, because this you need the combination. So the probabilities is the total number of the components, okay, will determine what is the total probabilities, okay. So you need the summation, so you need the sum, the multiplied, okay, the sum of the multiplied, okay, of each failure probability of each component, okay. So this is the equation that will be used to determine the probabilities and also the reliability. Okay, we will look what is the difference between parallel and also the series interaction. So this is series interaction. So for series interaction, you just need a failure of any single component. So just one component failure will result in series of failures, okay, result in the failure of the process, okay. Just need at least one single component to be failed, okay. So the series structure will be represented by the logical gate of OR, okay. We use OR gate, okay. For parallel we use AND gate, so for the series we use OR gate, okay. So the individual component of process reliability must be multiplied. Okay, as we compare the previous one, we use the individual component failure probability must be multiplied. Okay, probability must be multiplied. But for the total for the series, we use reliabilities. Okay, reliabilities must be multiplied. So for parallel, this is P. Okay, but for series, this is R. Okay, you can see the difference. Okay, so from your reliabilities, you can find your total probabilities. Okay, the equation is still same, but only the parallel and the series difference is their probability and their reliability equation. Okay, which one have to be multiplied. Okay, the difference in their logical gate and what is the combination that can trigger or can make the process fail. Okay, it's either a combination or at least or just one failure can result in process failure. Okay, for now you just need to understand what is the function of OR gate and AND gate. Okay, because these gates will be used during our fault tree analysis FTA after this. Okay, after we going further for the interaction between process unit, then we will look what is the fault tree analysis and event tree analysis. Okay, during the fault tree analysis, you need to use this AND and OR gate. Okay, so you have your AND for parallel gate, for parallel iteration, and then the OR gate for your series iteration. Okay, so this is the single component. Okay, or single process. Okay, single equipment. Okay, single component A and also the single component B. These are two different component, two different single component, but because of the interaction inside the system when what we call as a system 1. Okay, for example, system 1 consists of component A and component B. So component A need to interact with component B. So the interaction of component A and component B could happen, there will be some fault could be happen during the interaction. So what is the probability of the failure happen in this system? Okay, in this system 1. So the probability, okay, we use, okay, because this interaction is in series, okay, is happen or the probability of the incident occur could be either from A or B. Okay, from A or B. So the probability A or B to happen or to be fault is equal to probability of A, total A, probability of B, okay, minus probability of the overlap of A and B. Okay, because this is the overlapping, because you have twice. Okay, this area have been covered twice if you don't include the minus PA PB. Okay, this is the mathematic equation. Okay, PA or B is equal to PA plus PB minus PA PB, because there are two layers of overlapping here. Okay, however, for some cases, the area of the overlapping is very, very small. Okay, sometimes near to 0.003, 0.002. So the minus PAPB can be omitted. Okay, so to summarize, we can call as the probability of A or B to occur is equal to probability of A plus probability of B. Okay, this is the summarized version when the overlapping part is so small. Okay, because sometimes it's very small. But you can still use the PA plus PB minus PAPB to calculate the probability of incident to occur. Okay. Okay. The question is, how about the iteration is parallel? Okay, what if the component A and component B is in parallel, in parallel interaction? Okay, when you say that component A and component B in parallel interaction, that means that component A and component B must be failed simultaneously. Okay, must be failed simultaneously so that the system 1 will be failed. Okay, because the first one, okay, the one that we discussed earlier is the series. Okay, so if the component A and component B in system 1 have been or been connected in series, okay, only a failure of A or B can be resulted in system 1 failure. But if the component A and component B are connected or are related through the parallel interaction, component A and component B must be failed simultaneously so that system 1 will fail. So if system A and system B have been connected in parallel, the overlap area here is the probability of the failure of system 1. Okay, PAPB, the overlap area here will determine what this is the probability of failure for system 1 if these are connected or interact with or via a parallel interaction. Okay, so I hope you can understand what is the parallel interaction and also what is series interaction. Okay, to summarize, this is the types of component linkage and also what is their failure probability, okay, reliability, and also their failure rate mu. Okay, what is their R, what is their P, and their mu based on their interaction. Okay, so remember this is OR gate, this is AND gate, this is for parallel, this is for series. Okay, so for series linkage, you see the difference between the equation for the series and parallel for probability, reliability, and also their failure rate. Okay, this is the summarize of what we have learned for today's lesson.